I'm here to talk about some more unit circle stuff. So hopefully over the last little bit when you're working with that simulation, doing a couple of problems, you're starting to get more used to the unit circle. Here I'm going to label it in terms of radians. So here I'll have 0, I'll have pi over 2. This is also known as 90. Pi will be located over here. 3 pi over 2 is down in the bottom, and then 2 pi all the way around here. So remember 2 pi is just 360. This down here is 270. 180 and 90 degrees. So what you've noticed in the last couple of days is that we will have a radius of 1 to any point along the unit circle. We create a right angle triangle with any of these scenarios where the x step is given off of the center over this way and the y is given this way. We've also noticed that the cos of an angle is going to give us the x position on the unit circle, and that the sine of an angle will give us the y position. So traditionally we'd write this point in terms of coordinates as x and y, but now it's equally as acceptable to write them now as cos of an angle and sine of an angle respectively for for x and y. So if I were to say cos of an angle, and I were to say that this would be, I don't know, 30 degrees, and I wanted to know what this x point is right here, well, I would just crunch cos of 30. And if I wanted to find out what the y step was, but the y point here would be, I would just say sine of 30 would give me the value of that there. So more of that to come when we do trig equations. It'll become more and more obvious as we go along. So another thing that we would have noticed over the last little bit would be that there's some rules to follow when we're dealing with the quadrants, right? So you would notice that the C quadrant falls down here, A, S, and T. So this is basically saying that all cos is positive, this is all is positive, sine is positive up here, and tan only is positive down here. So tan is positive on these two quadrants because tan is the gradient, which is sine over cos, and notice how the tan is always going in the positive upward sloping direction, and then if you're looking at it this way, tan is again the gradient here going from left to right, it's sloping down, so that's why tan is negative in these quadrants as well. And of course this whole side here, x is positive, therefore all and cos is positive, and on the left hand side here all the cos is negative. Same with the sines being positive on top and the sines being negative on the bottom. So more of that to come as we create our class set of notes on Wednesday. What we're looking at now, though, is we're noticing a couple of interesting things about the unit circle, and it has to do with how we graph a circle. So I know that the radius of a circle can be given by x squared plus y squared, or sorry, the equation of a circle, x squared plus y squared will give me my radius squared, I guess you could say, and that's usually in a lowercase, so let me fix that here so it's r squared. Now I know that the radius of a unit circle here for me is going to be 1, and that holds true for all unit circles. So really x squared plus y squared in this case will give me 1 squared. Now, because we know that x's are coses and y's are sines, we can substitute this in and say cos squared of an angle plus sine squared of an angle is going to equal 1 squared. Now, one thing that might be funny is where we square these things. Now, just for your information in terms of where these squares show up, we actually draw it inside after the cos. And the reason why is so that way we don't square the angle, we actually know that this whole thing is cos squared. And if that's a little bit confusing, just ask your teacher and we'll be able to coach you through exactly why that exists. So here we know that cos squared of theta plus y squared, cos squared theta plus sine squared of theta is going to equal 1. Now, what does this really give us, right? So what does this exactly do in terms of the application? So if I were to draw in the unit circle that I have a specific angle and I have a value, right? So I'll move this up here for us. Now let's say that I have this value up here, and let's say we want to find the possible values, find the possible values of sine theta when cos theta is equal to 1/2, right? So cos theta is equal to 1/2. Now, if I were to look on my unit circle, I would say, okay, I got a couple of options here because, there's going to be a positive and a negative bit for this cos. So I'm going to draw a line off of here. Let's say cos is equal to, like x is equal to 1/2. I know that cos is going to be equal to 1/2, and I'm going to draw a line right down through here. So at this point where x is equal to 1/2, where cos theta is equal to 1/2, I know I'm going to have cos theta sine theta, and I know that this is going to be 1/2 comma something, right? So sine theta is still unsure. This one down here is still going to be the same thing, where this point is going to be 1/2, which is the first bit, the x bit, and it's going to be sine theta as well. So what you'll notice here is that there's two possible answers for sine, right? So I can have sine up here, where it's going to be positive, and sine down here, where it's going to be negative. And this is where we use this identity in order to figure out what those things actually are. So I would take this and I would plug in my given information, which would be cos theta is equal to 1/2. So I'd say that 1/2, and I'm going to square that, right? So 1/2 squared, right? Because I just put cos theta inside, I still have to square it, plus sine squared of theta is equal to 1. I have to do a little bit of rearranging here, so I'd sine squared of theta is equal to 1. I bring this over, so I have to subtract, so that's 1 minus 1/2 squared. Now, you have to be careful with this. The square goes on the top and on the bottom. So this is going to be sine squared of theta is equal to 1 minus, now I take the 1, so 1 squared, and I'm going to have to say that that's going to be 4, because that's 2 squared down on the bottom. All right. So the one thing that you're going to have trouble with is simplifying fractions, surprisingly. So this one right here, I can rewrite this one as 4/4 because I have the same denominator as the number that I'm subtracting. So it's really important to have the same denominator. So 4/4 minus 1/4. And so here, I'm going to be saying that sine, and this is going to be 3/4. I'm going to take the square root all in one step. So this is going to be the square root of root 3, right? Root 3 all over the square root of 4. But remember, when we take the square root, it's going to be plus or minus, right? Because as seen in our original diagram, we'll have a plus answer for sine and a minus answer for sine. And I can square root the bottom, so I'm just going to tidy this up a little bit, and I know that, I forgot sine theta, I know that sine theta will equal plus or minus root 3 all over 2. So that means that here, this value, this one right here, will give me a plus root 3 over 2. And this one right here will be the minus root 3 over 2. All right, so this is really telling us that we're going to have two possible values. So usually these questions will be prompted with find the possible values of sine theta when cos is equal to 1/2. So really it's just plugging it into our original cos squared plus sine squared equals 1 equation and simplifying things all the way down. You will have two answers when it says possible values. All right. So moving on to another question where things are a little bit trickier. So I'm going to draw my unit circle again, and this one isn't nearly as nice, but we'll get used to it. So pi over 2 up here, pi, and 3 pi over 2 down the bottom. And so this type of question, the next one will be find the exact value for cos theta if sine theta is equal to 3/4, and this is an interesting part. So, and if the angle lives between, so this is the angle, lives between pi over 2 and pi, right? So this is the lives between, I guess you can kind of say these, right? So lives between these two things. So the angle must be found in the quadrant, right? So the quadrant between pi over 2 and pi. So I look over here and I say, well, between pi over 2 and pi is going to be in this quadrant right here, and I'm going to be looking for I know that my sine is going to be 3 over 4, so let's point that here. Let's say that this is cos theta, and then sine is going to be 3 over 4. So it's a little bit chunky in my yellow over there, but you get the point. So this is where this point is going to be. Now, what this is saying is in this general location, there's going to be two options. There could be one down here, but the question is asking us specifically to fill out the answer for just this quadrant. So the one down here does not matter. We don't care about this one. We only care about the top one. All right, so we're going back to figure this one out, and this is going to give you an opportunity to disregard one of your answers. So cos theta, cos squared theta plus sine squared theta is equal to 1. And so I'm going to plug this in. It's a lot like the first type of example where, you know, cos squared theta plus 3 over 4, and that's a squared. Fix that. So minus 1, or sorry, equals 1. Cos squared theta is equal to 1 minus. I'm going to do this all in one step. So I'm going to say 3 squared is 9 and 4 squared is 16. And then from here I have to make sure that I have the same number on top and bottom in order to subtract that fraction. So cos squared of theta is equal to 16 over 16 minus 9 over 16. And cos squared theta is equal to so 16 minus 9 is going to be 7, and 7 over 16. If I take the square root of this, so I get rid of this, I'm going to say that this is the plus or minus version and take the square root of both of these things. So I'll be left with plus or minus root 7 all over, and I can take the square root of 16, so I'm going to say that that's 4. Now, remember that theta, right, so this angle, right, so this angle lives between pi over 2 and pi, right, so right here I know that cos, right, this cos is going to be negative, right, because it's in this quadrant. Remember how we say C, cos is positive only, A, all is positive, S, only sine is positive, and T, only tan is positive. So here in the S quadrant, cos is going to be negative. So while we have two answers, because cos of an angle, right, cos of this angle is going to equal negative root 7 over 4, due to the fact that our angle lives between pi and pi over 2. Right? So it is a negative cos because we usually have two answers unless told that we're trying to find the exact value for cos. All right? So there's two examples of finding possible values and exact values using cos and sine and the general relationship between the two functions and how they're related to the unit circle. So these were a little bit confusing. Maybe watch it again or consult your textbook or maybe ask one of your teachers, but please try to watch this one before you come into class next day. Thanks for watching.